Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Farag al-Amoudi, a student at Al Schools, and I'm a part of the Honors Calculus class. Here is a project about the area between curves. Let's take the first example, an area to a region in a function. First of all, the function, as we can see, the function is x squared plus 6. And here it requires us to find the area of the shaded area between x equals 1 and x equals 2. As we can see, the first step we're going to do is we're going to have to draw the graph of the function x squared plus 6, which is going to be this right here. As we can see, the inverse parabola. Second thing we're going to do is that we're gonna put we're gonna shade, or we're gonna put a line on where we're supposed to calculate the area, which is from x1 to x equals 2. As we can see, here is x1, x2, and inside the function we're gonna shade it, and we're gonna have to find this shaded area. Then we're gonna put it into an integral to find the area of it, of the shaded part of the function. An area is gonna equal to the integral from 1 to 2 of the function itself, which is negative x squared plus 6. And then we're gonna get a result of the area being 11 over 3 u squared. Let's go to another example of the same thing, about an area to a region in a function. Here it says the function is x squared, and he needs the shaded area. He needs us to calculate shaded area from x equals 0 to x equals 3. First of all, the first step we're going to do is that we're going to draw the graph of the function, which is x squared, which is a parabola. As we can see here, we just drew the function, which is a parabola. And now we're going to have to find the area of the shaded part, which is from x equals 0 to x equals 3. We're going to put a line here, we're going to put a line here. We're going to shade or highlight the area between the curve and the x-axis, which is this one, as we can see here in green. And now we're going to put an integral for it, and we're going to solve for the area. As we're gonna get a result for the area, which is the integral from 0 to 3 of x squared dx. The area at the end is going to be 9 u squared. Let's take a third example. This one is going to be an interesting one. Here it's an area between two curves where we are going to have two functions, and we're going to have to find the area between them. First of all, the example says find the area between the curves of the functions. First of all, we have the first function, which is x squared minus 3. The second function, which is x squared plus 7. The first function, which is fx, and the second function, which is g of x. First of all, we're going to draw the graph, and we're going to find that the shaded area between them is this green shaded area that we're going to have to find the area of. First step, we're going to find the intersections between them. We're gonna have to put f of x equals g of x, and we're gonna get a result of 2 x's, which is x equals positive square root of 5 and x equals negative square root of 5. That's the limits we're going to have in the drawing, which is the shaded area that we're going to have to find the area of. So these are the limits, and the function. Then we're gonna we use the equation. Okay, first of all, we're gonna put a line where we need the area of, or where the intersection is, which are these 2 points, which is plus and minus square root of 5. And then we're gonna do the integral of g of x minus f of x. Why did we choose g of x minus f of x, not the opposite? It's because g of x, as we can see in the drawing here, g of x is the one on top. So we're gonna put the integral from negative square root of 5 to positive square root of 5 is equal to g of x minus f of x dx. And then we're gonna substitute values, and at the end we're gonna get this equation, and we're gonna have to do this integral, and at the end we're gonna get a result of 29.814 u squared. That'll be it for the area between curves and finding the shaded area in this integral lesson. Hope you had fun and understood the lesson. Thank you so much for listening, and have a good day.